Hi, good evening, everybody, to the Potpourri, March Potpourri. All right, so we've got a packed agenda today, very exciting topics coming up. I'd like to introduce Chris Malicki, who's going to present a travel story, specifically astronomy in London art, astronomical themes and painting from the great London museums. Chris.
Thank you, Scott. Over the years, this is my fifth talk about seeing astronomical themes in museums in great cities. I did a talk on Florence. I did another one on Venice. I did one on Rome. I did one on Paris. 2 weeks ago, my wife and I took a holiday to London, and we were visiting only art museums. Next slide. In any case, so we want to see art, but I know that when I look for art, I'm always looking for astronomical themes, and I went without any expectation about what to see. I didn't research in advance what to look for. I just said, I'm going to go to these galleries, enjoy the art, and if I see something interesting that has to do with astronomy, I'll take a picture of it, and maybe I'll have enough to give an interesting talk, and that's what happened. So, what art museums are we talking about? Well, in the middle, you've got the National Gallery, and right beside it, the National Portrait Gallery. They're in Trafalgar Square. Just to the east of them is Spencer House with the Courtauld Gallery. Spencer House is a very old, fabulous house, and it's got a beautiful gallery in it. The Wallace Collection is a private gallery northeast of Hyde Park. And the fifth museum was Tate Britain, which has mainly great British art. So without further ado, what did we see? Well, in the Courtauld, I'm looking at paintings, and lo and behold, look at this one by Rubens, from the 1600s. There's a starry sky, so I'm looking at all these stars, like, do I recognize any constellations? Is that Scorpius way on the right? No, there's just too many stars. It doesn't make sense. Maybe there's a Pleiades and a Taurus above the tree, but no, not really. I was getting a bit disappointed. And then suddenly I looked carefully just to the upper right of the full moon in this painting, and on the left, you see sort of a blow up of that part, and I've cut out the part. And to me, that looks almost exactly like the water jar of Aquarius. So maybe Rubens had a point there. Like perhaps he actually saw Aquarius and he painted it just as it is. Like it's remarkably similar to what this Sky Telescope map looks like. So I thought that was pretty cool to see that. Okay, so why am I talking about rainbows if this is astronomy? Well, I worked for the Observer as a volunteer for the Observer's Handbook, and there's a huge section in there on atmospheric phenomena, and they go and there's a few pages on rainbows in the Observer's Handbook. So for me, that's fair game for astronomy. So for a really good bright rainbow, you have an inner bow and an outer bow. So the inner bow is the brighter one, and the longer wavelengths are on the outside because they're refracted less, and the violet and blues are on the inside of the primary bow because they're refracted more. I won't go into the physics of that. It's all in the Observer's Handbook. And if you have a really bright bow, you get a secondary bow on the outside, which reversed colors. So look what I saw in the Wallace collection. I'm going there, and there's another Rubens from 1636. And what do you guys think of that rainbow? Like, is it a real rainbow? Yeah, like I was a little bit disappointed. I mean, the spectral sequence is correct. The blues are at the bottom, the yellows at the top, but where's the red? And then I thought, then in the middle of the night when I had insomnia, I thought, well, maybe red pigments weren't invented at that time. But then I went back, but look, the girl and the guy, they're wearing red shirts, so that's not a good excuse. So beautiful painting, but Rubens blew it a little bit. So that's in the Wallace collection. And then several days later at Tate, Britain, exactly 200 years later, the famous landscape painter John Constable does that rainbow. And look, there's a primary and a secondary rainbow. And the spectral colors are correct, but again, like the rainbows aren't like quite what I'd expect. I expect them more brilliant. Like you'd want to see red and orange. So even though the colors are in the right positions, they're just, I don't think the colors are very nice, even though it's a beautiful painting. Um, well, the many of these things are restored, and like look at the rest of it. This is 1836. It's not, it's less than 200 years old. Yeah, who knows? Perhaps. Okay, so in Tate, Britain, I'm walking along the galleries and I see three paintings. Like the story is really depressing. It's about an adulterer and this, but I was really captivated by this picture of the sky. So I made a blow up of the right-sided painting. There's a gibbous moon, and it looks like in 2 hours it's going to occult that bright object. And I kind of thought, what is that object? Like there's nor is it written what it is. So I had to figure it out. Like, what do you guys think? What is the moon going to occult? Okay, any other choices? Yeah, Jupiter. It can't be Venus. Why not? Because it's a gibbous moon, and Venus is usually fairly close to the sun, and this object is very far from the sun because the moon is going to be full pretty soon. So that's got to be Jupiter. And if you looked at the sky today, you would have seen the moon between Mars and Jupiter. So not quite this kind of sky, but I think that's Jupiter. I looked on the web and there's no indication of what that is, but I'm sure that's Jupiter. Okay. The Observer's Handbook has a whole section on clocks and timekeeping. So I thought it'd be fair enough to throw in these almanacs from 1741 from Louis XV from the Wallace collection. So you could see there's the signs of this, there's the months, you've got the zodiac signs, and you've got the different days and the saints of them. I didn't take a picture of the other two, but there's 4 of them for the whole year. And talking about clocks, so I thought this was interesting. There's time in the Observer's Handbook, so this is relevant. I think there's sort of a map of the sky on this clock. So essentially what it says in here is that the pendulum was invented to make the clocks run accurately, and the pendulum was very long, so the clock had to be really huge, and so it became a real art piece and sort of a furniture piece. So there's some beautiful original clocks in the Wallace collection. And I really, really like this mantle clock. It's showing 3:16 in the afternoon. That's the exact time that I took that picture, 3:16 London time. Okay, and I couldn't resist this in the same gallery. I look into one of the cabinets and there's this pocket sundial compass, and you can see it's a sundial and it's like it's almost 500 years old. Like I thought that was really cool. Okay, and also in the Wallace collection, like it's filled with thousands of wonderful objects. Here's a writing set that belonged to the daughter of Louis XV in the 1700s. So on the right side, you can see the whole thing. So I made a blow up of the main parts on the left. So there's a celestial globe on the left, and you could see there's a Leo and a Ursa Major there. And when you'd open it up and the sun would illuminate it like probably a candle or something. On the right side, there's a terrestrial globe, and you open it up, and Louis XV's daughter would put her pen in and she'd write a letter. And when the letter was ready, she'd pick up the crown in the middle and ring, and a servant would come and take her letter. Like, beautiful piece. Yeah. Some of you might remember a few years ago, I gave a talk on Leda and the Swan, and my father really liked this mythologic thing, and he painted Leda and the Swan. So this is astronomical because Jupiter becomes the swan. Now, Jupiter is the king of gods. So if he came down and was with a mortal, the mortal would immediately die because Jupiter is so powerful. So Jupiter would change himself into less threatening things. So he becomes a swan. He goes, visits Leda. Leda was a queen of Sparta, and she had seen her husband earlier that evening as well. So when she gave birth to Castor and Pollux, Castor was the mortal son of her husband Tyndareus, but Pollux was the immortal son of Zeus or Jupiter. And when Castor died in battle, Pollux was so heartbroken that Jupiter put both of them in the sky as Gemini the twins, Castor and Pollux, as a reward for their brotherly love. I have two more mythologic scenes that I discovered in some of these paintings that are also relevant to astronomy. I really like this one. In this, I don't like the title, and it doesn't look like that's what's going on, but I love the painting from the 1600s. Here, Jupiter, in order not to destroy who he's going after, turns into a bull, and he takes Europa, who's a daughter. It says there on the plaque what it is. So no sense going through all of that. But the whole point is that Europa is one of Jupiter's moons. Like the four Galilean moons, Io, Europa, Callisto, and Ganymede and Callisto are all consorts or lovers of Jupiter. Ganymede happened to be a boy, but so this is relevant to astronomy with why one of the moons is called Europa. And I have one more mythologic scene that I came across in the Foretold Gallery. Beautiful painting. So there's Perseus, like Andromeda has been chained to a rock by the sea monster, and Perseus comes, slays the monster, and frees Andromeda, and they both go into the heavens, and the two constellations in the autumn are side by side, Andromeda and Perseus. And who is this? What constellation is the sea monster in the autumn? Sorry, yes, Cetus. Set is the whale. That's a sea monster. So that's the astronomical theme here. Okay, so we're going through the National Gallery, and my wife Liz says, "Hey, look, hey Chris, look at this. Oh, it's a picture of an astronomer." So yeah, well, how do you know? Well, the celestial and terrestrial globes in the painting identify this figure as an astronomer. Suppose suggests he is in contemplation. That's what astronomers do. We contemplate. Okay. So, yeah. Well, 1650. Well, yeah, telescopes were invented there. That's true. Now, one of my great discoveries was this one, totally unexpected. Like you go there, you don't know what you're going to find. But what's amazing in this room, like after we'd finished, we were about to go out, and I said, I'm going to read the plaque that's right by the door. And there's a picture. I took a picture of the plaque on the left. Public lectures of the Royal Society to the day of the United Kingdom's leading scientific academy were once held in the Grand Council room that we were in. They ranged from astronomy, mathematics, to biology, and physics. Groundbreaking lectures included William Herschel's announcement of the 1781 of his discovery of the planet Uranus. So we were standing in the room where Herschel announced his discovery of Uranus. Like imagine that. I had no idea that I was going to be in there. And we just went there to see the art. So there's my wife sitting in that grand room, and she took a picture of the National Portrait Gallery of me with Herschel, which I'm getting to in the next slide. So my wife Liz also found this wall in the National Portrait Gallery, which is got some fabulous art. So there's William Herschel on the left. John Dalton is beside him. Now Dalton, he had the theory of the atom, that all things are made of atoms and atoms are indivisible. And there's a unit called the Dalton, which is 1/12 of the mass of a carbon-12 atom. So that's what a Dalton is. So it's essentially the mass of a proton. And then on the right, there are three women astronomers, which I'm getting to in the next slide. So The most famous one is Caroline Herschel. So I made a blow up of her on the right side of the slide. So, okay, so Caroline Herschel became a celebrated astronomer, even though she had no formal education, was largely occupied as assisting her brother William. Okay, Donna. So she discovered 8 comets. So essentially, while Herschel was examining the skies, his sister Caroline was doing the notes and recording everything, and she was a really good astronomer in her own right. There's the other 2 women in this in here are Margaret Bryan on the upper left. So taught astronomy, natural philosophy when girls received little education, and that's relevant for tomorrow, which is Women's Day, I think. And then in the bottom, you have Mary Somerville, self-taught, wrote a 1826 paper on the violet rays of the solar spectrum. She was the first person to be described as a scientist. So that was sort of nice to see a recognition there. And also in the National Portrait Gallery, you've got a nice painting of Edmund Halley, of Halley's comet fame, and there's Sir Isaac Newton on also in that gallery. Okay, thank you very much.
Wonder if I could ask Joe to come down just for 2 minutes.
So this was alluded to at the AGM, I think it was the AGM or the last meeting. But one of our members has completed a observing certificate. Kirby Aguirre. That's completed with the telescope. It was very well done. So we have a certificate and a pin. And an envelope. If you like. I don't have words.
You two could have one of these.
Yeah. One of those. I don't have very good words. I'll work on that. I'll get that.
The best words.
Congrats, Kirby. Any questions for Chris? Fascinating talk. Amazing talk. Thank you very much, Chris. So you've inspired me when I'm in Vienna next time. I'm actually going to a few museums. Maybe I'll put. Maybe we'll see. Yeah, we'll see. Yeah, for sure. Okay. Next, we would like to welcome Chris McNeely, who's going to present a book review. And he's going to talk about a history of the universe in 21 stars and 3 imposters by Giles Sparrow.
So here it is, tonight's book review. I'll leave it here if anybody wants to have a look at the break or between talks. So as Helen just said, this is a history of the universe in 21 stars and 3 imposters. Giles Sparrow is a UK-based writer. Has anybody read any of his works? He's got probably about a half a dozen books out. Varied topics from Mars, the planets, constellations, and then he had a more recent one on the Hubble telescope. And he's also a fairly regular contributor to Sky at Night magazine. I was thinking of our annual meeting and where this may be suitable is I think, John, you mentioned there was 86 or so, 85 so new members last year. Yeah, so it's almost a quarter of our membership. So I thought this thing might be good for our newish members of the club. So the author says in the book, he's picked 21 stars for a variety of reasons, and some of them, like 61 Cygni and Sirius B, have played a unique role in our discovery of our place in the universe. And he mentions among the other 21, Aldebaran and Eta Aquilae are good representations of broad families of objects to help us understand the wider story. So the difference in this book, this is a narrative history of astronomy framed around 21 stars. So those of us who are familiar with conventional astronomy textbooks or astrophysics textbooks, the chapters may be organized about, say, stellar brightness or radius and how we calculated temperature and so on. This is structured around 21 chapters of stars, and the 3 imposters were once thought to be stars, but one of them is Andromeda Nebula. So the structure of the book is a little bit different. It's non-technical, no formulas, no equations. written in that easy narrative style, rather casual style. So it's a novel approach. There's some handwritten notes in here. They're pretty casual. If you're looking for something, you know, the more intermediate advanced astronomers that maybe want to take a gander at it, you'd obviously want something more precise like a star atlas or on Sky. I think it's, yeah, Sky Safari or some other app like that. So it's very casual, very written. I'll refer roughly later on to some of the passages, some of the wording. So I'll give you an example of some of the stars he talks about. Talks about 61 Cygni in Cygnus. Anybody familiar with that? It's a nice little double star, widely spaced, couple of orangish, easy with binoculars. So he refers to this star in this particular chapter on the development of the parallax measurement tool and how it led to a further advancement in how we measured distances of stars out there and added to this database. And he refers to, you know, early pioneers like Frederick Bessel, who at the time measured this particular star, 61 Cygni, roughly 100 times. And this was back in the early 1830s or so. And what he came up with was estimates of the stellar distance in light years and the rotation period, orbiting period of its double, that other little orange that's whatever, 32 seconds, I guess, distance. Anyway, so that was one advancement. And then the author quite really points out that once we got beyond the Earth's atmosphere with spacecraft like Gaia, and prior to that, the satellite Hipparchus, it just opened up whole new opportunities. The other one that he picks out as an example is Aldebaran. So I was pleased to see, I don't know about you folks, clear skies tonight. So Aldebaran's over here. It's probably what, 5 degrees from Jupiter right now. So he illustrates with the topic of Aldebaran is a different usage of analyzing starlight, or what you call spectroscopy. And he talks about the early pioneers, Huggins and Mueller and Fraunhofer's studies of the late spectrum. And 2 fellows in the UK, Huggins and Miller, looked at Aldebaran's
Yeah, hey guys, I just wanted to quickly share my trip to Australia. Sorry if I'm a bit woozy. I landed yesterday and I'm just jet lagged. But yeah, this was a real off-the-cuff trip. I was just, work was getting a lot and I kind of just flipped the table and decided to go somewhere, anywhere. Ended up in Australia. Didn't really have a theme, didn't really have a plan. So I kind of just, walked and drove wherever I kind of wanted to. And there's a few pictures I took. Actually, I wasn't even doing a lot of astronomy related stuff until I saw an email from Swapna about talks. And I was like, oh, wait, there's like an observatory in Sydney and stuff. And I can just kind of run over there. And it was the last day because they're only open Wednesday through Saturday. And it was Saturday at like 6 o'clock when I reached the hotel. And then I kind of just like, and they close at 7 and I kind of just power walked all the way to the observatory. And it's super hilly and my cardio wasn't the best. And I was just on my knees like that. But I successfully reached there, only to find out that there was a massive event for Ramadan going on. The iftar party when they break the fast in the evening with, there's a lot of significance to the moon and stuff. But basically what that meant was everything was closed. Nothing was open. I couldn't really go in or anything. But, people are people. I kind of just weaseled my way in, I just brown nose. I'm like, oh, hey guys, this is so cool. What's going on here? Stuff like that. And then, I kind of just started talking to the volunteers and stuff. But yeah, this is the observatory. You can see the dome up there and then the living quarters on the other side. I'll have a few zoomed in pictures, but So whatever I'm talking about here is just my observations. Stuff like you see the living quarters on the other side of the dome, the windows are bigger, there's more light going in, but the windows on the observatory side, they're just slits, very small. Which would definitely help with observation, especially from in the middle of the city. I later read on Wikipedia this was built in the 1850s-ish. Not much light pollution at that time. And I think they stopped using it around 1980s. That's probably when it got too bright to use. But one observation I did have throughout my whole trip, the skies in Australia are just a lot clearer for some reason compared to ours. I guess it's just the weather. They don't have a lot of clouds, but even then it was just bright for some reason. I don't know the reason. It was just super bright and nice. Yeah, this is just a close up. You can see the thing I was telling you about the windows near the observatory. They're just very tiny. That's where people worked and did observations and stuff like that. And the living quarters on the right for the astronomers, those windows are bigger. But unfortunately, I couldn't go in. But there were a few volunteers there who were managing the event. You can see there's like a bunch of picnic tables, people breaking fast, and then behind the observatory is where people were doing the prayers and stuff like that. But there were a few volunteers, and I kind of got talking to them, and then they took me to like a thing they had set up for the kids. Keep the kids busy as they're running around while the parents are doing the prayer and stuff. And sorry, there's one more picture here for the small windows. And another angle of the observatory, you can see the dome. The domes, yeah, they tried to refurbish it as much as they can. They don't use it anymore. I think the original telescope is still there. It's like a 7.5-inch refractor. But of course I couldn't see it. But yeah, I got talking to the volunteers and they took me to the place where all the kids were hanging out and they had these set up. And I was like, guys, it's the daytime. What are you guys looking at? And they were looking at Venus. Yeah, and then there was still I was just they was just treating me like some random annoying person who just walked up to them until I got talking to them. I'm like, oh, what phase is Venus on and stuff like that, and that sort of started the conversation, and then we got talking a bit more. And I told them, okay, yeah, I'm from Canada, and I love astronomy stuff. It's a real shame I can't get in. Wink, wink, nudge, nudge. But they didn't have the keys, so unfortunately I couldn't get in. But yeah, this was really nice. This is an SCT Meet 8-inch, I think. And I have the same one, but the Celestron, the orange tube one. This one is a Skywatcher, the one on the left, the tiny one. But yeah, they had it pointed up to Venus. And it was nice seeing Venus again. They were really nice people. I got into an argument with one of them when I asked them, I'm like, oh yeah, you guys have the moon upside down. And they're like, no, you have the moon upside down. We're the right side up. I'm like, I don't know. We were just talking about how like stuff is it was a bit of like a Twilight Zone thing. I was just talking to Sapna about this. Australia is so similar to Canada, but it's just different enough that you just stop and you just notice those differences, and then it just kind of catches you off guard. Like you look up in the sky and stuff is just out of whack. I don't know how to explain it. It's just different. And even the culture and everything, it's very similar to Canada, but just different. They call their AC air cons, the vernacular, the slang and stuff like that, But yeah, it was a trip. It was a trip. This is the astrograph. This was in Melbourne, and then it got moved into this observatory in Sydney. And then, they stopped using the observatory in 1980s. But this is the astrograph, and you can even see the picture on the left on the wall. That's the like a wide view that they took of the night sky, southern night sky. I think the Carina Nebula, the LMC, the Large Magellanic Cloud, is in there. And yeah, it's just a really big, giant metal piece of equipment. There's a chair. Person would look through the finder, and then have the star in the crosshair, and then take pictures and stuff like that. But one of my favorite things about the observatory was just appreciating the sunset. I've never done that, come to think of it. I've never just stopped and looked at the sunset. I really appreciated it. But as I was walking by, I just saw a lot of people just stand and start taking out their phones and just start looking at the sun and take pictures. And, I kind of wanted to get in on that. So I stood there for like a good 15, 20 minutes, and it was really nice. The beautiful clear sky. The sun went from yellow to red, orange to red. Um, it was a real, and just the background, the harbor, the water in the middle, and then the other side of the city. Just, yeah, I took one small picture without getting in people's way. Everyone was, and this is just like a small slice facing the front. On my right and left, there were so many people. And with the kids, the telescopes I showed you pointing to Venus, they were right behind me up at the observatory. And all the kids are hanging out there, and they're whooping and cheering about the sunset. Like, look, mommy, it's red now. It's going down. I saw it move. It was it was really nice just appreciating the sunset with everyone. Um, there's some really nice pictures. I only included two here, but yeah, that was really special. I've never really actually stopped and admired the sunset this way. But basically, since Australia is so similar to Canada, I spent a few days in Sydney, and then I was like, okay, this is pretty similar to back home. I don't spend a lot of time in Toronto either. Yeah, it's the same thing. So I kind of just rented a car off Turo and just started driving wherever. Basically just up north, 5 hours, 6 hours. Just drive until I get tired and then just stop for a night at a random hotel or an Airbnb. These are some of the views. Really nice. I had to like sort of tweak the colors a little bit, so that's why they look weird. In fact, all the pictures after this will look a little bit weird because I didn't have my gear on me. I just had my phone. So no long exposure, shaky hands, all that kind of stuff. But it was just really nice. I was jet lagged at this time, so I was wide awake at 2 a.m. And this is the picture I took. It was just like a lookout point. And oh my gosh, the town in the distance, the sound of the sea, and so many stars. Holy cow. It's just, I couldn't pick out constellations. There was just too much going on up there. I'm pretty sure. So for a solid week and a half, I was like, okay, I can see the band of the Milky Way. I can see that blew my mind from my backyard sort of thing where I was staying. I could see the band of the Milky Way. And does this look familiar to anyone? It's this is what I was saying. It's the Twilight Zone episode. It's like everything is different but the same. Like it's upside down. This just broke my mind when I took a picture. It's Orion is upside down. Like I was like, what? It was yeah, it was just the Beetlejuice is on the right bottom, and it's just stuff was upside down, and it reminded me of the argument I had with the volunteer over there. I was like, you guys are upside down. Like, no, you're upside down. This is just a random picture. I just took pictures here and there wherever I could. There were just so many stars I couldn't identify constellations except for Orion and stuff like that. You can just see Orion at the bottom. This is another one. So remember I was telling you I can see the band of the Milky Way? And I'm like, it looks very cloudy. What is that? What is that? And am I just losing is that the band of the Milky Way or is there something there? So I took a picture. I went back in my room. I uploaded it on astrometry.net, I think, where you can upload a picture and then it'll plate solve for you and let you know the slice of the sky you took a picture of. And turns out this is the Great Carina Nebula. I didn't even know what that was until I Googled it. And yeah, it's a large diffuse nebula, 4 times bigger than Orion, super bright. I could see this with the naked eye. That's why I took a picture. And I thought that was really cool. When I looked it up, it's a lot brighter, a lot bigger than Orion, but it's not as famous because it's in the southern hemisphere. But I thought that was really cool. Just from my backyard, I could naked eye see a big nebula, and I really wished I had my gear on me. I could take a few pictures. It would have been nice. This is another one I saw naked eye, the Large Magellanic Cloud. It's actually a dwarf satellite. So again, I didn't know what it was until I put it in a plate solver, went inside, Googled it. But it's a dwarf satellite galaxy. To our galaxy, it's a satellite galaxy to our galaxy. It's a dwarf galaxy, about 50 kiloparsecs-ish away from us. And again, another large naked eye object. And, that just blew my mind. I could see all these things naked eye. Sorry.
Trying to identify the star.
Yeah. Yeah, and the picture quality is a bit shoddy because I used my phone and my hands are shaky. Um, but yeah, it's I thought that was really good. LMC, the Large Magellanic Cloud. Ferdinand Magellan was so he didn't discover this or anything, but he documented it, brought it back with him to the Western world, and that's why we kind of ended up naming that. There's another one, Small Magellanic Cloud. I couldn't see that with the naked eye, but it's pretty close to that one as well. But yeah, I thought this was cool. Here's another picture of the upside down shenanigans of Australia. That's a waxing crescent moon on the left, but it's flipped the other way. Like that broke my mind. I was like, wait, am I remembering my phases wrong? What's going on? This is from my hotel room. It was very cloudy. The moon just peeked out for a second. I quickly took a picture. And the one on the right is from my home in Mississauga. You can see, like, it's a few days after. But yeah, it's facing the one, facing the other. I really wish I had paid attention when there was a full moon or something like that. The features of the moon would have been upside down. That would have been cool to see. But yeah, overall, fun trip, good trip. Spent a lot of time just relaxing. I didn't do any of the touristy stuff, so I just kind of went where the day took me. And yeah, finally this bird tried to steal my lunch. It's an ibis. It was standing super close to me. That's why I got my camera out. And the moment it saw me like distracted with my camera, fiddling with my phone, my hands off my lunch, it just started stealing my food. Like I had to yank it back. I'm like, this is not good for you. Give it back. Go eat some bird food. This is human food. It knocked my drink over and everything. And yeah, it's the Australian ibis. I asked the local and they call them bin chickens over there because they keep going through the trash and stuff. So yeah, got my food stolen by a bin chicken. Scary looking birds from far away though. I was like, holy cow. Started taking a picture, it stole my food. But yeah, that's it, guys. Any questions, comments? Huh? Oh, so remember I was telling you there is a party for the iftar party for the Ramadan? So the volunteers laid out like a mat. So when they break the fast with the food, people could sit there, but they were running a bit late, so we kind of just hijacked the area, started taking pictures. No one came to lay down. But I think this would have gone into the night where, you just lay down, look at the stars, that type of thing. But it was for the event. We weren't really allowed on there. But yeah, this is one of my favorite pictures, actually. It's really nice.
Commissioner Robinson,
Oh, yes.
what cell phone did you use?
Oh, it's just the S24. Sorry, I'm not too technological. Samsung S24 Ultra. Neat. I think it's the same. Yeah. Neat. I didn't even know that I had a 200 megapixel camera until the sunset picture, actually. So all the star pictures are kind of crappy, 12 megapixel. This one is nicer because I found out that there's a nicer camera on there.
Ready?
Right, I'm just wondering how, is this the main harbor? Are you very close to the bridge and the opera house?
Yes, I didn't include a few pictures, but yeah, this is very close. So Opera House was on the east and the observatory is here facing the west.
Oh.
So it's the other side. Oh yeah, because the sun's setting. Yeah, it's facing the west. But Opera House was on the other side. Pretty nice. In fact, I even took a picture. I forgot to include it. I made this on the plane, guys. I'm sorry. It was a long plane ride. I made the presentation on the plane, but there are a few more pictures. Like there was one when I was taking the ferry from Sydney Harbor to Circular Quay to Darling Harbor, and the ferry went down this waterway. The picture I took, and I could see the observatory from the ferry. Took a picture of that as well. Yeah, it was nice. It was nice. A lot of ferry rides. A lot of ocean. The water was warm. I went to the beach. That gave me a shock. I put my foot in there, and the seawater was warm. Like I'm not used to that in Canada. I get frozen over if I put my head in any body of water here. And it's actually warm. I'm like, holy cow, it's nice.
All right, thanks, everybody. Okay, we're going to give Ron the control of the mic over here. He's going to take us to, not to Australia, not to London, not to planet Earth, but all the way to Mars. So Ron.
That with your iPhone?
No, I have a Samsung as well. Hi, everybody. This is a longer talk that I gave to a group at the David Dunlop Observatory, and I shortened it a little bit because I know there's it can be a long meeting, but there are just so many fascinating issues for me on this. Okay, trips to Mars, and the two issues are getting there and surviving there, and both of them are going to be difficult. Okay. Question: who launches the most rockets? Any thoughts? What's that? Okay. Well, I deliberately didn't say, but the answer, as said, is this guy who was in my talk before he became a political issue. So we'll ignore that side. But I personally think he's an incredible genius for what he's done. And part of it is his hiring. And I think he probably hires people that would never get hired by the established companies. He looks for a quirky behavior, and he asks some sort of goofy question like, what African mammal would you like to be and why? And he doesn't care what the answer is, but he wants somebody that can quickly think and respond. And he also always asks engineers, the second one, and the listening to somebody who faced a problem and worked out a solution. To me, that would be gold if he got a good answer. And he has an amazing result. Tesla, he only started up, and his company, I think, is worth more than many of the other auto companies. Revolutionized electric cars. SpaceX, of course, he's come up with new inventions such as, why do we have to throw away the first stage? Why don't we recover it? Which drastically cuts the cost. And my picture shows the Starship actually being captured on the gantry. And there's not much talk about it, perhaps because the underground, but he has a boring company, and beautiful pun, eh? I look at where it takes 10 years to make something like the Eglinton subway, and he is probably putting his ingenuity into that. So he's a real genius at coming up with things, and he's being recompensed for it. And all of us have goals in life, but his is only modest. He only wants to make humanity a two-planet species. So that relates to Mars. He's even got one of the launch pads for sending the Apollo missions to the moon. And I did a tour. I was with my brother, and we went to see a shuttle launch with Julie Payette aboard. And there was a big thunderstorm, so we couldn't watch it the next day. And so we took a bus tour, and it was really fascinating. I remember there was a zip line from where the capsule was during launch or before launch. And if the astronauts had to, they could take the zip line down and get into a bunker if there was some reason for something or other. And I didn't know that. Anyway, then we ended up, I don't know if I can point, okay, you see this? Then we went to the Apollo Saturn V Center, and the bus dropped us off, and we saw a relatively boring movie that I'd seen. And they said, okay, now go through a pair of doors. And we went through these doors, and we saw that. Now, I've seen the model of the Arrow, which is up near Stainer, and it's basically sheet metal, painted white, beautiful model, but it could never fly. Like it doesn't have real engines and everything. My understanding is this was a real rocket with real parts, and in theory, if Congress had authorized the money, it could fly. It could have flown. And we spent 2 hours just going back and forth, looking at different details. It was really fascinating to see. And I think you can all tell who my brother is there. This is a chemical rocket. And they take two chemicals that react really quickly. And the first stage was kerosene and liquid oxygen. And they react quickly, and the chemical energy causes the gases to expand. And just like if you're on a boat on calm weather and you want to move backwards, if you throw something hard forward, Newton's third law says you go back. but there's only so much energy. And it turns out almost all of the fuel in the first stage is not lifting the astronauts to the moon, but it's lifting the fuel on the second stage that then is lifting the fuel on the third stage. So most of the fuel is just getting up there because there are no fueling stations so far found in space. So here's the message, and it launched. It took 3.5 days to get into lunar orbit, a day to get the orbit circularized and everything and to check everything out. Landed in 1/10 of a day or 2.5 hours. And then it took less than 4 days to get back home again. Interestingly, it took 21 days for the parade, but the reason for the delay is the astronauts had to be quarantined because they didn't know if there were any germs on the moon that would cause problems. So I love this picture where the moon was about to cover Mars. I saw it when the moon passed Mars, and to see the red planet next to the moon, it was just stunning. And if you ever see a chance for that, it's worth a drive of 200 kilometers to see it. It's just stunningly beautiful. One of my favorite things. So how long do you think it'd take to get to the moon? Any guesses, as rather than people that know the answer? I'm just curious. Does anybody want to make a guess? Sorry, to go to Mars and back. How long it take to go to Mars and back? Any guesses? Pardon me? 18 months? Any other? 2.5 years? Any others? 4 years? Okay. I'm going to go through the reason it takes a while to get to Mars. I call it the tyranny of orbits, and this has got to be one of the worst solar system diagrams because the inner planets are really close together and the outers aren't, but it's there. And I say specifically for chemical rockets, and I'll explain what I'm getting at. Okay, here's the Earth orbit, and in 365 plus a bit days, we end up back January, February, March, and we end up back in the same spot. Well, however you define it, but basically compared to distant stars and seasons, you're basically at the same spot. And that's what we call 1 year. Now, if you have a comet, the Earth's orbit is mostly a circle, but if you have a comet, it's elliptical where it, and if one has the same perihelion, which is this spot closest, and the comet orbit, it's a little faster there. And as it goes further away, it slows down and it has this slower here, faster at the other end. And this is a pattern of comet orbits. And if there were a planet up here, this would be a little slower than there. Now, Mars, I made these diagrams and I started Mars a little ahead of the Earth because that's what you have to launch. And I just go January, February, March, October, November, December. After 1 Earth year, the Earth is at the bottom where J is, and Mars is a little over halfway around. Then you keep going January, February, September, October, November. In mid-November of the 2nd year, Mars has completed its orbit. So it's 22.5 months or 1.88 Earth years. Opposition is the most exciting stage of Mars, and we're passing on the inside. We're moving faster and it's shorter. And Mars is closest, it's brightest, the best views then. And the opposition this year was in January 15th. It turns out the distance, no, let me go back one. It turns out Mars has a very non-circular orbit, and it's closest to the sun when it's around where we are in September, and it's furthest away from the sun in March. So you have further away, and the next slide shows that the year of oppositions are very drastically different. And 2018, it was a doozy and a good one. But 2025, I don't even think there was a cover story on one of the astronomy magazines about it. I don't remember one. So it comes, we're in a few periods of there, but 33 and 35 are going to be really good. So whether we launch then or not, but it does vary from season to season. A German guy named Hohmann figured out that the least energy to get to Mars, to another planet, would be an ellipse, and it's called after a Mahoman transfer orbit. And basically, we're already moving at 30 kilometers a second around the sun. And if we just add 3 kilometers per second, and we launch and we time it to meet the other planet when it's the other side of the solar system, that's the way to get to Mars in the least energy. So it turns out, using my system, that if it launches at the beginning of January, by the way, this is for no particular year, it ends up getting to Mars around mid-September, 8.5 months. So one answer to the question is it takes 8.5 months to get to Mars. And you land on Mars, you plant a flag, you salute, you whatever they do. It would be difficult to have a conversation with the president or the prime minister or the general secretary or whatever the title of the leader is, because there's a time delay. And after you do all that, then the astronauts say, okay, let's go home. Well, the problem is, if we're at Mars in mid-September, the Earth is scooting away at 30 kilometers a second, and it's almost halfway across the solar system, and it's very difficult to catch up. So that's not going to work very well. So what you do is you wait. So 8.5 months to get to Mars. 15 months is the wait. 8.5 back. So 2.5, 3 years is roughly the time. So who said 2.5 years? Okay. Oh, well, okay. Anyway, and that's what chemical rockets will do. So now I'm going to talk about getting there. All sorts of new ideas. There's a standard size capsule, but maybe they can make an inflatable place that people could use for exercise machines or whatever. This is the Apollo service module. It's almost the size of a basketball hoop in terms of diameter. It's got hydrogen and oxygen for fuel for the rocket. And the third stage sent it towards the moon, but this slowed it down getting into the moon, and it gave the energy to get out of the moon. But you also need electrical energy, and the hydrogen and oxygen combined in a fuel cell and made electricity. And the oxygen also provided for astronauts to breathe, but the carbon dioxide that breathed out had to be removed. So they had canisters of basically a solution like lye. And this thing was for 8 to 12 days. So the last missions were 12 days. A Mars trip would take 25 times that just to get to Mars, and hundreds of times to go to Mars and wait and then come back. So the amount of materials that are needed are immense. Well, why don't we make materials? Okay. Hydroponics, you can grow plants and they take carbon dioxide out of the air and they make oxygen. But you need a bigger spaceship that's heavier. And the other problem is that, according to Wikipedia, these are the top 5 devices that are plants that are growing. And I love eating the first 5, but I wouldn't want to live only on lettuce and tomato and peppers. Sorry, it's kind of a boring diet. So you'd need a larger spaceship. Has anybody actually been to Biosphere 2 in Arizona? No? It's an amazing place. They got millions of dollars from some donors, and it's made out of glass. This is a photograph, by the way, they grow a whole bunch of plants in there. And the idea is you have 8 people that live there permanently and see if you can make a separate ecosystem where the plants make enough food that people can survive. And they had different duties with farming and whatnot. And they decided to have animals, so they had some predators and prey. And apparently the mouse all get eaten by the cats, and then the cats all died. So a simple ecosystem is not very stable. But the biggest problem, well, 2 problems. The oxygen got reduced because there was some reaction with the concrete. That's what I read. And the other problem is that the team of 8 got into massive philosophical arguments, and they hated each other, and they were glad to get out of there. In other words, it wasn't a successful event. I'm astounded that nobody in this group has been there. I haven't been to Arizona myself, but it would be interesting to visit. I understand the building is still there. Other problem is bone loss. When astronauts land on Kazakhstan, they can't walk. They have to be carried. This is after being in space for a long time, like going to the moon and back. It wasn't long enough, but they lose muscles. And that's even after 2 hours of day exercise. And as you can tell, I don't do 2 hours a day exercise. And as an astronaut, to be like this all the time, it wouldn't be very exciting. And even with that, they still have bone loss. Radiation's a big problem from solar flares and cosmic rays. And I often did experiments with my students where I put the paper on top of the magnet, sprinkled iron filings on, and you get this pattern of the shape of the magnetic field. And of course, the Earth has that. And our Earth's magnetic field is gold for us. It deflects particles from the sun. It protects us from a lot of radiation, but not all. But even more important, it protects our atmosphere. Because Mars is smaller. It's so small that the inside isn't liquid anymore, which causes the problems. So what happens is the atmosphere is mostly blown away. Mars used to have more water and it was a nicer environment than we are, but it's gone. Interesting, in 1972, that was the last year for the last two Apollo missions, 16. And my second favorite is 17. And I love this photo of Harrison Smith, the only geologist who ever went to the moon. With that, right, it's just so desolate. But how many of you know what happened between? In early August that year, there was a major solar flare that caused mines and harbors to blow up. Now, what would have happened if the astronauts happened to be in space at that moment? Not too healthy. NASA has a phantom torso with materials that are similar in radiation absorption in our bodies, and they have all sorts of meters. They're studying all this. Another issue is morale. If you're stuck in a spacecraft for 8 days, you can sort of endure, like Buzz endured Neil's, whatever, like they had a professionalism, but in 8 days you can put up with anybody, but 3 years, I don't know, that's an issue. And Antarctic, they had ways of keeping morale up. Anybody know what movie this is? What's that? Yeah, 2001. And here they hibernate some astronauts. Research is ongoing. Somebody said in 10 years they're going to do the first test, but I don't know. That's one way of solving the problem. Now, maybe there's a faster route. And this is just my analysis. I haven't read anything about this, but this is just my analysis. Remember I said you need 3 kilometers beyond our speed to get to Mars by the slow route? Maybe there's a route where you could wait until maybe a month before opposition, zap to Mars quickly, land, salute the flag, etc., and then head back. And that would be a shorter trip. But just my back of the envelope calculation, it would need something like 30 kilometers a second of acceleration to get there. Then you'd need the same, you'd have to fire a rocket to slow down when you're on Mars so you can land. Then you'd have to accelerate to get out there, and the chemical rocket fuel would just be incredible. But maybe there's another energy source. In the core of our sun, hydrogen atoms combine to helium. It's a little more complicated than that. And there's massive research to figure out ways to make a fusion power station. And here's an artist impression of one based in Vancouver. But look at how heavy that structure is. There's no way you can fly that to Mars. Or maybe you could make a fusion reactor. And here's a sketch of it, possibly. I couldn't find any distinctive reports on it, but it could be Elon has a team working on it and making success. It's very cheap to make paintings of nuclear reactors, but so far these haven't done. And I personally think you're going to need some faster way to get to Mars and back than chemical rockets. Antimatter? Maybe. Scotty worked it, but it does exist. It's real stuff. But I think there's a lot of years of research before we can efficiently make antimatter and then find a way of storing it and then using it to create energy, but in theory it's possible. Landing on Mars. Not easy. This painting shows a capsule. I don't know which one, maybe it's the Apollo one. And when it hits the upper atmosphere, it gets super hot. They have either insulating tiles like the shuttle, or they sometimes have substances that flake off in the heat. And that slows it down enough that they can pop a small parachute to slow it down a little more, and then a bigger parachute, or maybe just one, I'm not sure. The problem is the Mars atmosphere is 1/100th, 1 divided by 100 of the thickness of the Earth's atmosphere. So the ability to slow down in Mars is a lot less than Earth. So right now, the landing sequence for the latest rover is it gets into the atmosphere, it drops some stuff it used for traveling across. Then you get the heating. It slows down enough they can pop 1 or 2 parachutes. They drop the heat shield, and then eventually this sky crane drops it, and then the wires are all cut off, and the rover can just go like a newborn gazelle in the savannah, can walk right away, apparently. Okay, I don't know if you can launch a bulldozer on that, though. Like, a bulldozer so big, and the air friction is limited, and I don't know whether you could launch a bulldozer. Surviving on Mars. Sometimes it's warm, but usually it's really cold. So they need accommodation right away. I didn't know where to put this, but if you're on Mars, in essence, you're in a company town. And I took this picture of Timmins. Sorry, I went one too far. This is the lake, and across there is the mine. And when the company owns all the houses, you're kind of subject to abuse. But if worse comes to the worst, you can always just walk and hitchhike and get out. But if you're on Mars, there's no way to leave other than the company saying, okay, you can be on these flights. So there could be abuses. The atmosphere is thin, mostly carbon dioxide, which induces sleep. So whatever you need oxygen, and you need some device to remove the carbon dioxide. Interesting, NASA included in the latest rover the MOXIE, which makes oxygen from the carbon dioxide. The problem is it needs energy, and the device for 2 astronauts is about this high. It takes 25 kilowatts, was like 2 toasters going flat out, and maybe 200 square meters of solar panels. But the problem is that Mars has dust storms. So can you rely on solar panels for power? Maybe you could make radioisotopes, but even they, in 17 years, the plutonium partially decays and you get a reduction. Are there other energy sources, fission, fusion, antimatter? I mean, who knows? But these are issues that I think have to be resolved. Okay, I took this picture, and I wish I'd got more of the gravel. If you have any surface on Earth where the plants are removed, very quickly seeds land, and you're going to get growth. And the corn in the background, when it's harvested, you're going to find thistles and whatnot, goldenrod are going to grow through it. What about Mars? If you land a seed on Mars, is it going to grow? Well, A, it's cold. B, there's not much water other than near the poles. And C, I don't see an awful lot of soil there. Here, pictures, that looks sandy to me. I don't think that's any good. But the worst problem is the soil on Mars has chemicals, perchlorates, that are poisonous. And if you're going to grow things on Mars, you've got to remove the perchlorates, which can be done. But that's another task to make it harder. And you'd probably have to grow things underground because, for temperature. And of course, you can make oxygen and carbon dioxide, etc. NASA has a challenge for people to convert carbon dioxide into sugar, and they've got some, promising technologies. I talked about radiation. from the sun and the cosmic rays, and the Mars atmosphere it's not thick, and there's no magnetic field. And this is the Matt Damon character growing potatoes in The Martian. But the problem is that there's no radiation protection there, and he probably couldn't survive the radiation. And this is a great big fancy painting, but again, if there's a city underneath that glass dome, very little radiation protection. But they're lava tubes. Who's heard of lava tubes, by the way? Hey, wonderful. There are lots of lava tubes on the on the moon. This, of course, is, I think it's in Hawaii, but I'm not sure. And basically, when lava flows, it melts the soil underneath it. And for some reason, sometimes you get a top on it. And that would be a good place to live, except here's a sideways view. And you have a collapsed trench like the Apollo 15 site. And there it's open. And sometimes you have skylights. And they're neat, except underneath the skylight, you've got a whole bunch of debris that would be very difficult for astronauts to clamber down. And here's a picture of one lava tube or skylight on Mars. I tried to find information about skylights and lava tubes on Mars, and it was really hard to find. And here's a map of all of Mars, and I could only find two. And this map is color coded. So this blue is really low, yellow is intermediate, and red is high. And the only lava tubes I could find are by volcanoes, which are high up, which means it's hard to use the atmosphere to lose energy. And is that where people want to live on Mars? So maybe lava tubes on Mars aren't available. Maybe they'll have to use boring, Musk's boring things, but that's heavy machinery. Kennedy gave a speech, and other people other politicians have said, instead of we're going to the moon and coming back, we're going to go to Mars. That seems to be repeated by politician after politician. And I thought he said, we choose to go to the moon, not because it is easy, because it is hard. I thought he was just being poetic. But actually, I think a major motive for the Americans to go to Mars was to beat the Russians and to show that the American system can do something the Russian system couldn't do. Maybe some people would argue against that. And if it was just to launch a two-person spacecraft, the Russians would beat the Americans. I don't know if 62 of they've done it, but they clearly could beat the Americans on that. So they needed a project that was long-term that the Russians couldn't do, and it worked out fabulously successful, except for the magic, the unlucky number of 13. Okay, here's a lava tube. Maybe at some stage, lava tubes are likely to be bigger, by the way. Maybe at some stage they will make underground structures and maybe start playing sports. And a sport would be completely different on Mars because gravity is less and the air thickness is less. But maybe at some stage in Mars, you will end up with sports. And if that happens, then clearly we would be a two-planet species. Anyway, thank you very much. And if there are any questions, I would.
Chip, how many you would need
To go to Mars?
to go to Mars?
No. The more I think about it, the more there are massive things that have to go there, even to keep a team of, say, 5 astronauts alive, and you need a certain number because you need someone that's a doctor and probably a backup doctor, and you can't have a crew of 2 there. But I've heard no estimate so far of how many. I did hear somebody say Musk is planning to send humans to Mars in 2029, when we're about as far away during the opposition as we could be. But I don't think that's going to happen. Okay. Were there any other questions? I've asked 2 people. if you did a poll of space experts, just after Neil did his small step and giant leap and all that sort of stuff, and said, how long do you think it would be before there's going to be a trip to Mars? And I'd just like to get people opinions. How many think that if you asked 100 real space experts, I'm talking about real knowledgeable people, do you think most would say it would be 0 to 10 years? What about 10 to 20 years? Maybe. What about 20 to 50 years? Remember, we're talking about back then. Anyway, myself plus two others thought they would have guessed 20 years, but I personally think it's unlikely with all the issues that I've raised that they're going to get to Mars within another, I don't know, 30, 40 years, but Musk has a habit of doing things. Yes, good. Hi. Okay, the question is articles on AI. Actually, I haven't researched AI much. I know for sure it will be used and look at different solutions, designing fusion reactors. I know for sure that's being used because I'm following fusion reactors on Earth. It's something that I've been following. I know AI is used all the time, and but I can't see that AI can solve the sorts of problems I'm talking about quickly, but it will help design better rockets and etc. Okay. Yes, Alan.
Okay,
I mentioned the fission reactors and that's the idea, but any fission reactor is damn heavy, and you're going to have the first stage have to have enough energy to lift the second, third, fourth, fifth, and sixth stage to send it all the way to Mars, and then with enough fuel with it to slow it down. Because again, at least that can take the 8.5-month trip because you don't have to worry about feeding astronauts. It's just a reactor. And then you have enough rocket power when it gets to Mars to slow down so that it can land. Great idea. Whether it happens or not, I don't know.